Rats and demons. What's that got to do with math? Well, I had a former student once when we were talking about rationalizing the denominator. He thought it worked for him. He's like, okay, I got to rat the demon. That's how I'm going to remember how to do this one. You know, rationalizing, R-A-T, rats, demons, well, denominator. The first part looks like a demon. And I'm guessing at this point a lot of you are saying, yeah, math is like a demon to me. Maybe, maybe not. Okay, but we're going to be rationalizing the denominator here. So, you may have had this before, and I'm probably going to have to unravel whatever you learned from how you were taught this before. Okay, here's what I mean. 7 over the cubed root of 2. Let me come back to that and do this one first. 3 over the square root of 5. So the idea here with the 3 over the square root of 5, I want to get rid of the denominator. I want to get rid of the radical in the denominator. So what I need to do is multiply the numerator and denominator by, ready for it? By whatever creates a perfect square. Okay, do not think I need to multiply top and bottom by whatever the denominator is. Get that thought out of your head. If you learned that in the past, get rid of it, okay? Because that's incorrect thinking. You do not want to multiply top and bottom by whatever the denominator is. Okay, get rid of that thought. You want to multiply top and bottom by whatever creates a perfect square in the denominator. Okay? So in this case, if I multiply top and bottom by the square root of 5, I'm going to end up with a square root of 25 in that denominator, right? So in the numerator, I've got 3 root 5 over the square root of 25. See how I created a perfect square in the denominator? That then becomes 3 root 5 over 5. And that problem's done. Okay, now, again, I'm going back to the whole, don't multiply top and bottom by whatever you see in the denominator. Yeah, that's what's going to happen if you have a square root in the denominator. But what if you got a cube root in the denominator? So let me erase what I just finished here and come back to 7 over the cube root of 2. So first let me show you where people screw up. So don't do this. Say, oh, top and bottom, let's multiply top and bottom by the cube root of 2. No. Okay? That's where people mess up. And I can talk myself blue in the face, spend the next 10 minutes on this video, and I'll probably still have people messing that up on the test. Because I see that happening in my traditional classes. I talk myself blue in the face and people still miss it. I'd like to think they're the people that weren't in class that day, but no, they were there. I don't know. So, again, in this case, what we want to do, since I have a cube root, I want to multiply numerator and denominator by whatever's going to create a perfect cube, okay? I've got 1, 2 inside the radical here, which means I need 2 more 2's. So I'm going to multiply top and bottom by the cube root of 2 squared. Okay, or 4. You can write 4 if you want. Because what that does is it gives us 7 times the cube root of 2 squared, which is 4. But look at what happens in the bottom. That's a cube root of 1, 2, 3 2's. So 2 cubed, which is going to become a 2, right? So that's going to be 7 times the cube root of 4 over 2. And that problem's done. So hopefully you're understanding why you just don't multiply top and bottom by whatever the denominator is. Because if you look at this, my denominator originally was a cube root of 2. But I'm multiplying top and bottom by the cube root of 2 squared. Alright? Okay, now let's take a look at this last one here. I've got the 5th root of a squared over the 5th root of 32b to the 12th. Let me erase this over here so that I have some room to work with here. So what I'm going to do first is I'm going to suck out of the denominator any perfect fifth powers that I have, because I have some in there. The 32, that is a perfect fifth power. The 5th root of 32 is going to be a 2. And then I'm going to split up this b to the 12th so that I have b to the 10th times b squared. And the b to the 10th is going to come out because that's a multiple of 5 there. So how this is going to shake out here is I'm going to have the 5th root of a squared over the 5th root of 32 comes out, that's 2. 10 of those 12 b's are going to come out, and 10 divided by 5 is 2, so that's going to come out and become a b squared. And I'm left with the 5th root of b squared inside. Notice I haven't rationalized the denominator yet. I'm about to, but I had some groundwork I had to cover ahead of time. Now, hopefully you figured out by now that I can't just multiply by whatever's in the denominator to rationalize the denominator. It doesn't work that way. I've got 2 b's inside that radical of the 5th root right now, right? How many more b's am I going to need to get to a fifth power? I need 3 more, right? So I'm going to multiply top and bottom by b cubed. See how that works? That puts us at the 5th root of a squared b cubed. That's all going to be inside the umbrella of the radical there. And in the denominator, I've got 2b squared. And then I'm going to have the 5th root of b to the 5th, which is going to become a b, right? Which will multiply to this b squared. So my answer, if I can write it here, is going to be the 5th root of a squared b cubed over 2 b to the 3rd. Now that guy's done. So again, the moral of the story on this rapid demon here is multiply top and bottom by what will ever give you a perfect square, 3rd power, 4th power, 5th power. Depends on what your index is, okay? Again, I'm just going to close with this comment. Do not multiply the numerator and denominator by whatever the denominator is. Just get that thought out of your head, all right?